Welcome dear students, we are on the CEC-UGC lecture and we are the series of the electronic circuit, and today we are discussing the inkjet printing and the other printings. So what are the main factors which influence the printed electronics? We will discuss some of the points, the main influencing factors in the printed electronics. Number one, the control of the ink dropped, which is very important. The print head temperature, the centering or the cure of the ink, and the printing control of each layer are the key parameters to ensure the quality of a multi-layer printed structure. So, if we talk about to evaluate the properties of the substrates such as service temperature, its barrier properties against the humidity, electrical, optical, mechanical and the chemical properties of the substrate is important. As ink is important, so in the ink is control of the ink in the form of the drop is very important. Second, we talk about the substrate whose properties is very important for the printing the particular structure on the screen. So, equally important is considered the receptivity of the ink by the substrates. Means when we are printing something on the substrates, it receptivity is very important. With the moreover already structure is printed, so previous it is also possible for the previous printed layers in case of the different ink has been used, means multiple layers we can draw on it. So the droplet size can vary depending on the interaction between the ink and the substrate. So droplet size should be vary so that according to the requirement it can put on the substrates. So the droplet size sets the width of the printed line, establishing the pattern, space and the electric design limits, and defines the final specification of the printed patterns and the application system like resolution, bandwidth in case of the printed electronics. During the manufacturing step, the printed pattern characteristics are dependent on the material and their interaction. Means this is also the influencing factor in the printing electronics. The properties of the ink must be chosen in advance to understand its behavior during and after the printing process over a given substrates. Sintering and cure of the conductive material are essential because it defines its chemical, electrical and physical performance and the reliability of the printed layer over the long time. So these are the some influencing parameters in case of the printing electronics. Now, next type of technology in the printing technology is in the printing electronics. The next type of printing technology is the extrusion based printing. The functionality of the extrusion or the filamentary based printing is similar to the FDM system, which is based on the high temperature melting of the fuse on the controlled motion across the XYZ plane. Means we can do the 3D painting by using this. It is a layer by layer extrusion based printing technology that is used for the accurate fabrication of any three-dimensional layer structure. Means by extrusion we can prepare the three-dimensional layer structure. The extrusion based printed electronics are highly suitable for printing the complex 3D microstructure with superior electric properties, like which depicts the graphene based flexible conducting line deposited on a surface of a globe for sensing strain, pressure and EMG sensor. Means we have a we can print this type by using the extrusion for the sensing purpose. 3D printed CU copper based filament has been extensively used to build the printed electrical interconnection, metallization and the circuit. So similarly we can use the copper just for the connection, but it is in the form of the like a very small structure we can use. In addition, the multi-layer metal interconnects and their electrical performances across the three embedded interconnect metal layers, we can use this technique. The electrical conductivity of the interconnects is further tested by the PIC control based printed circuit board to further evidence the capability of the digital data transmission across the printed the metal lines. Solar cell using a FDM process and the fabricated solar cells have a cell size of 25 millimeter or with the 200 micrometer as a MAP thickness, means a very small thickness type of solar cell can be obtained through this technique. And the transparency at a elevated temperature due to increase the electron hole pair generation in this case. Fabrication of the prescribed solar cell further realize the possibility of utilizing the commercial application because of the simple and efficient process technology offered by the FDM. Now we can see on the screen, this is a fused deposition of the graphene based flexible conducting lines on the wearable gloves as sensors. You see here we are having the ink, we have a material, after that deposition has been done. Now here the sensors are made by using the deposition. These are the nano sensors which are prepared by the printing technology. After that you see the device, the gloves which having the pattern of the sensors, and these gloves are the flexible device, and that can be that sensors can work on the movement of the gloves or the movement of the device through the gloves. So another type of printing is the light based printing. Here we use the UV curing as we can use for the additive manufacturing techniques for the building the complex 3D structures. So light based printing, where the UV curing techniques have received the increased interest recently due to their fast curing, high resolution, energy efficiency, less space, solventless process. So here we use the ink which works based on the photopolymerization or the photo curing process. So photopolymerization is based on the transition of the liquid phase inked to the solid phase under the UV or the visible light irradiation. Means light based printing where we use the ink, liquid ink, and it convert into the solid phase device, and by using the UV or visible light irradiation. You see on the screen that this is a device which is used for the preparation of the by using the liquid we can convert it into the solid, or we can just pattern it. You see upper part is the device and lower part how the cantilever the nozzle connected with the nozzle print on the substrate. This is the one of the method. In general, it is the oligomers based inks which use for the photo polymerization. There are the many resins, epoxies we can use. We can use the polyether, we can use the polyesters, and we can use the epoxy resins for this purposes. One droplet UV assisted printed by using the bottom up UV illuminated printing. So it depicts a typical experiment setup for the one droplet UV illuminated printed technology by using the UV curable resin droplet. We can easily understand that we are having a 3 different substrate on which just one droplet used for the preparation of a small device. So it is developed on the 3 different substrates. These substrates are F quartz, and second is super amphiphilic, and third is SPDMS. Now we are having, you see on the screen that these are the three substrate on which the droplet is put. You see B, H and N. You can see here that this is the surface dimension of the droplet on the substrate. So on this three substrate we can just print by taking the droplet. This data we have taken from the reference paper that defined that the author has found the one droplet UV illuminated resin which is grown on the F quartz and the super amphiphobic surface, and which is ruptured curing and curing the with the vertical strips patterns. So UV curing on the SPDMS substrates has better resolution than the other counterparts. That is recently developed paper by the scientist Zhu et al., which reported the NRI laser 980 nanometer assesses the photo polymerization technology for the development of a small feature size of the 4 mm 3D complex structure. Means a very small 3D complex structure can be drawn by using the NIR, near infrared laser, which is of the wavelength 980 nanometer. You see, you can easily see that how this device are prepared by using the 3D technology. Now, the scaling ability of the NIR laser by developing a mesh like pattern with the line width of the 400 micrometer. Similarly, a honeycomb like structure is also showcased in the 3D printed monolithic structure at different resolution, which shows the freestanding cantilever structure with color different pigments. The proposed structure represented the freestanding and direct ink writing technology. You see, this honeycomb structure is also printed. This can be seen through the size. You can see the size, it is 1 mm and it is of the 5 mm. So this small structure can be drawn by this. Another type of the printing technology is the electrohydrodynamic printing. In this type of printing, it is another interesting type of the inkjet printing system used to deposit the functional ink in the form of thin films, as well as it is just to give the high resolution patterns. As we already discussed that this technique is costly as compared to the other inkjet printing, but high resolution patterns we can prepare by using this electrodynamic printing. So it is considered of the high speed camera, light sources, nozzle head, ink storage and supply mechanism, the stage movement activity display unit. So working principle of EHD system is that the ink to be deposited on the substrate is pumped from the ink storage tank to the nozzle with the appropriate ink flow rate to make the stable cone jet. Through the special cone jet, the ink will ejected. Positive voltage is applied to the nozzle. The end ground is connected with the substrate holder. The induction of the substrate charges on the pendant meniscus emerging at the nozzle outlet, resulting in an electric stress over the ink surface, and on the basis of that electric field and the flow rate are in the some operating range, then this will overcome the surface tension stress over the ink surface and result in deformation of the droplet at the orifice of the nozzle into a conical shape. In a conical shape, a droplet will come out through the nozzle. While sweeping the high voltage from the 0 to the required value, different modes of the spray occur, including the dripping, unstable, stable and the multi-jet mode. So electrohydrodynamic jet, that is also called the E-jet printing, is just produce a high resolution printing, and this printed liquid is driven by an electric field. Exposure to an electric field causes mobile ions in the polarizable liquid to accumulate at the liquid surface. So, Coulombic means if we take the repulsion of the ion causes the meniscus at the nozzle and to deform into a conical shape, and that is called the Taylor cone. Now, when the electric field exceeds a critical limit, the stress from the surface charge repulsion at the cone apex exceeds the surface tension, and the droplet of the fluid is emitted towards the grounded substrate. So, we can see here the E-jet printing. You see here this is defined as the 0 to 30 pulse black, this is the 0.30 back pressure has given to the system. Then there is the there is a nozzle, you see on the in between that there is a micro pipette we use, then NICR heater, and then stabilizer we can use. After that the 5-axis stage and the stage heater and the cantilever. You are seeing in the inset that the piezoelectric pressure is given to there, and then it will eject the droplet of a particular size, and there is a cantilever on which the droplet will be gone. So, the key to the high resolution droplet printing are to use the electric field potential below these required for the atomization mortar and the spray mode, and as well as use the small micro pipette nozzle with the diameter less than of the 10 micrometer. So, you can see this is a schematic diagram of the electrohydrodynamic system. It means we are having a nano sized droplet through this nozzle, a very small sized droplet we can use by this nozzle. So, this is a schematic diagram in which we can define the various how the ink will go to the nozzle, how the electric current is passed through the nozzle, and how it will come out from the size of the ink droplet which is coming out through the nozzle. After that it will deposit on the substrate, and then it will just store on the substrate, and then that is further using. So, these are the electrohydrodynamic modes which is defined for the droplet of the ink. So, next is the for the stable cone jet, appropriate voltage and flow rate are required with result of the uniform spray. So, the tangential electric field acting on the surface of the ink cone, a thin jet is used. So, for the further the stable cone jet mode EHD is ideal for printing and can be used for the thin film or the patterning depositing on the various substrate. Now, the cone jet expands at a substrate size and makes the spray at a distance between the nozzle and the substrate. So, the distance need to be optimized to achieve the stable cone jet desired for the thin film deposition. During the small standoff distance, cone jet is narrow and used for the patterning. So, E-jet printing for integrated hydrogel into the MEMS sensor. So, we can prepare the MEMS sensor. Sensors are used to measure the elastic and viscous properties of the nanogram scale samples, like we can have any polymers, hydrogels that we can use. The hydrogel mechanical properties were then modeled and used to measure the long term mass and mechanical properties of the growing cell. So, MEMS will be prepared by using this. This is a very simple diagram that is used for the deposition of the droplet. and the sensor is prepared. So, you see there is a micropipette that is then the current is applied, droplet will come out, then it will deposit on the substrate. So, a mass sensor is prepared. You see this type of the sensor we can prepare, that cannot be seen by the naked eye, but we can see through the system. So, what are the application of the EHD technology? As we can get the high resolution, it is cost effective inkjet printing process with the high resolution. With EHD printing, functional materials can be selectively and precisely printed on the desired substrate. We are having this application in different industries. Moreover, we can introduce the 3D printing. We can do the 2D printing by using this, and we can compare these printing. So, by using this we can the various type of printing. Another type of printing is the slot die coater. The slot die or slow mask coater is a special deposition technique where the material is printed on a moving substrate and installed directly on a roll to roll system. So, the solution is directly dispensed of the slot die print head in a controlled manner. So, this type of coating is executed in the two steps where a uniform and the stable flow of the coated material is achieved in the first phase. So, in the second phase, other processing parameters such as the standoff distance between the slot die opening and the target substrate, speed of the rolling substrate and sintering conditions in line to promote a multi-layer structure coating capabilities. So, in this the system is connected to a continuous flow of the material into a temporary reservoir at the print head and applied at appropriate amount of the rolling substrate. So, this type of coating technique is ideal for the large area deposition, such as we prepare the solar cell, we prepare the light emitting diode where high resolution patterning is not required. So, besides optimizing the rheological properties of the ink solution, system specific parameters such as the speed of the roll play a significant role in establishing the process in the safe and the stable operating system. The coating process can also be affected by the various defects such as the uncontrolled meniscus, moreover resulting in the dripping of a solution, air bubbles and the ribbing. So, proper control of the startup and shutdown cycles is highly demanding, as a minor deviation could lead to the deposition of the material at an unwanted position on the substrates. So, proper tuning of the material and the process parameters is needed, otherwise it would result in the wastage of the coating solution as well as compromising on the shape of the pattern. So, this could also significantly affect the thin film quality, result in deviating from the device real dimensions. You see on the screen, this is a very simple method. This is a slot die head. This is just coat accordingly. Ink is delivered, then through this a pattern is given to the system and then it will remain. So, it is a coating process on the substrate. A large number of the solar cell can be prepared by using this. So, material properties such as viscosity, surface tension along with the system parameters, slot size and the gap and standoff distances and decrease dip length, reduce the dimensions of the printing jet. Proper adjustment of these parameters leads to shortening the trial time required to reach the steady state condition. So, despite the high speed coating capabilities, the challenges involved in reaching the stable operating condition make the process less attractive than the other printing system, and it is adopted seldomly in the manufacturing of the printing electronic devices. After that, we can compare the contact and non-contact printing, where we have discussed the many techniques. So on the basis of the mechanism and its features and its challenges, we can just compare the contact as well as the non-contact printing, like LTW, like the aerosol, like we are having a IPT inkjet printing is also a very important point. So we just can take the various comparison of this contact and non-contact printing. Another point is the non-contact printing technique and it's challenging. Then how thickness we can get in any process. So and what resolution we get in any techniques. Moreover, the surface tension we can use it. So and what type of printing we can do by using this, how much size we can get it. So techniques, we have many techniques. So solid film deposition, how what substrates we can take in the various non-contact printing techniques. So if we talk about the aerogel, then what is a solution we can take, what type of ink we can take, what is the viscosity of the ink, as we are seeing on the screen that this viscosity is 0.001 to 1, or the thickness must be greater than 0.1 and resolution must be 10 to 250 micrometer. Similarly, IPT, we are having the water based, solvent based, and it is curable, so UV curable, so we can have the resolution from 15 to 100. Moreover, surface tension we can take 15 to 35. So in this manner we can develop the devices on the mass level. So mass production perspective we should keep it in mind whenever we select any inkjet print, and we can select any printing technology for development of the printed electronic device. So developing printing technology is motivated by the development of fast and effective production line by assembling the different manufacturing units, substrate treatment and sintering after fabrication. So highly optimized techniques we used for the development of a single device. Scope of such development is rendered from the high speed text printing based technology and the printing process matured at the mass level and the fast production with the same level of the performance. So we will further discuss about the printing electronics in the next lecture. Thank you very much.